Okay. Now, if you have the location for the equipment, you have consideration, I guess, structural limitations, the electrical equipment, electrical appearance. A lot of this stuff is what? How are you going to put the rest of the electrical equipment will look what? Appear to the customer. It's a problem. That's why manufacturers now, before what you had disconnect what? You have disconnect switches, you had what? Combiner boxes, you have the inverter, you have the connection, a disconnect switch after that, then you tied up to the system itself, you had all kinds of boxes. Now what happens is, manufacturers now were able to what? To integrate a lot of this stuff into one box, so make it what? Easier for the installation and more what? Appealing to the customer. So you see a lot of sometimes the combiner box, the disconnects, the DC disconnect, the inverter, the AC disconnect, it's all in what? In one little box. So now you're going to install one box instead of installing what? 4 or 5 boxes up there. Architectural appearance is what? Remember, the customer, what does the customer see? What does the customer see? The panels, a little box, and what else? The electric bill. That's what they see a lot. If it's happy with the appearance, and it's happy with the system performs, well, the cost may be one factor, but once it's been determined, you're fine. Here's a nicely, as close as possible together. This is a good installation. It looks really nice with little inverters. Here's the disconnect switches and all kinds of things up here. You've seen installations up there. I don't know, nice reputable companies that they do it over and over again. It looks like this. Some of the stuff that I've been looking at it, you see these things.
You have a picture of that?
Excuse me?
You got a picture of what you see?
What I see?
Yeah, well, nothing?
Generally, for the people who are in business, the work looks really nice. Yeah. Really, for people who are in business and they're doing these things for a while, because their reputation, don't forget, they stick also their name up there, their reputation. They have pictures on the internet so people can look at the types of system. So you don't want to show something that is really sloppy, okay? So people who actually they are in the business like this, they really do a good job and they really. Excuse me? Oh, they are, it's. There are times that some people don't forget your reputation depends on it. And what happens is if the customer doesn't like it, you're going to have to fix it. If the inspector, guys, and if it does fail inspection, then you have to do what? There is a point in the code that uses an electrician is it has to be done in a workmanlike manner. And there are some inspectors, you know how they force that particular consideration there. So this is a nicely done system. Okay. Now, when you start doing all this site analysis, the site should be what? Documented as much as possible, because you're going to use that to do your design, your planning, and you're going to prepare with installation, because out of that you're going to make a parts list, you're going to make an official drawing, you're going to plan, you're going to do a schedule, you're going to have now all the geometric dimensions, any kind of structural requirements that you may have, location, distances of components. If you have a tight space up here, you may select what? Different types of components. If you don't do one disconnect switches and everything, you might get an inverter that has all of them together. If it becomes more cost effective, have the material separate up there, you do the same thing. Very similarly, what you guys do what? You buy a meter stack or you buy individual meters for a trough and hang up your panels up there, right? Yes? Depending on your requirement, you make a judgment. Utilize any kinds of what? Media methods, drawings, pictures, and so forth to document, and you never know when you're going to have to prove it in the front of a lawyer that you've done the job right. Remember that. Remember that. So you have to put all this stuff in order, okay? Special conditions that you may have to worry about it, okay? Here's a typical drawing layout, site layout, okay? And then again, site layout drawings should base basic building dimension, location of major components. Again, a lot of the considerations, the best location has to be what? convenient access to array and electrical components. Should your system needs to be taken off, it becomes a problem with what? For the fire department. The fire department has a lot of saying all of a sudden, and it does with photovoltaic systems. Because how are they going to shut a photovoltaic system off? Disconnect the switch. What does that do? It just kills the power to what? To feeding into what? But the system still generates power. You know what's the easiest way for them to disconnect it? What? Take a look, go to the truck, get a blanket and put it over. What are they going to do? They're going to break it. They're going to break it because they're there to do a job, not to be nice to it. So they like the things to be grouped together. The whole thing is, and they were actually, when they were made the requirements, that they have to be accessible, visible, and so forth. When we talk about the codes, location of the disconnects, we're going to talk all the requirements that they have met with that. But the best thing is you have to have access to the array and electrical components. Why do you have to have access to the array? Because you don't want to do what? Go to the latest bedroom thing in order to get to the array. You have to have access for maintenance, repair, and to the electrical components of the system. You don't want any time that you have to do what? Any kind of service to tear the whole house apart. A lot of this stuff I say over and over again, and what happens is in the end, we'll do an energy audit, see what or a load analysis. Okay? You guys are good in that because every time you put a service in somebody's house, what do? You do calculations, okay? And then you say to somebody that you need a 200 amp service, okay? Or 300 amp service, okay? Or whatever you want to tell them. Do a load analysis. Why? Sometimes, and I have a little instrument. Guys, sometimes some of you, what you do is there's a little instrument up here, you plug it, you plug the actual load up there, and it gives you a measuring, okay? And you calculate how much average daily use that you have. Now, some of this information is available, estimated, best thing from the load analysis, use the electric bill. Okay. Sometimes, because here's you got to be smart. You got to be smart because sometimes by you doing the load analysis and efficiency, if you need let's say a 12 kW system, but you know you cannot install a 12 kW. You might be able to install a kW system, 10 kW. But you may inform the customer that they can do what? Some sort of an energy consumption methods by changing some of their system together. Maybe perhaps a better furnace, a boiler, and so forth. And plus with some of the rebates and so forth, it becomes what? Cost effective. Now you've done your job and actually you inform the customer of other methods. Lighting, for example, it's a big deal now. So just because you're selling a solar system up there, that doesn't mean that you cannot be educated enough to use other options. And a lot of times, air conditioners, refrigeration, you get a lot of HVAC people involved into this solar business too. So it's a business. Okay. Most of the types of equipment that actually are energy efficient, they have the energy guide up there for them and give you the operating costs and so forth. Food for thought for the customer. You sound very what? Intelligence. You do a performance estimate, okay? Some of the systems, you just put them in the house to give you enough energy, okay? That's it. We put it up there, they're going to give you 3 kW, and that's about it, okay? Typical standalone system, okay? Now, those systems, usually you're going to size based what? On the requirement for the load. So if you want 3 kW, you put a 3 kW system up there, account for some of the losses up there, and that's all you get. If you get interactive systems, so they don't have any kind of battery backup, then you have no problem as far as how much power you can generate. So you design the system based on what? On the maximum power output that you can get. So if you have an area up there that is large enough, and you can get a lot of power up there, you explain to the customer, this is how much you get. You generate more than he needs, you get it back to the what? To the utility company. Be smart on those things. This is, again, what your initial survey should do. Understand the customer. There's no reason that if the customer, let's say, needs about 3 kW, and if you give him 5 or 6, you have the